we are going to start with the basic principle of organic chemistry. This is one of the chapter which is leading to foundation of organic chemistry. Once you are through with this, then the rest of organic chemistry would be quite easier to understand, and therefore it's very important to understand the principle underlying this one, and it's equally important to understand the facts and the principles described here, so that the rest of the organic chemistry would be enjoyable. So to begin with, we can simply look at the carbon atom. Since we are talking about organic chemistry, so essentially it is the study of the compounds of carbon, and so you must be aware of the fact that carbon is forming 4 bonds like this one, and with this, or it may be C double bond C, or it may be C triple bond C. Therefore, based on this, you can say this is sp3 hybridized, whereas in this there is 1 sigma and 1 pi bond, which is 1 sigma and 1 pi bond, and therefore we can say this is sp2 hybridized. And in this case there is only 1 sigma, and again there is 2 pi bonds. Therefore we can easily say that here, that in this case carbon is here, the carbon atom is this carbon, and this carbon is sp hybridized. So definitely I have just left these bonds. So similarly we can also formulate 2 more bonds there like this. So the trivalence is completed. So one very important aspect is there, that is how many sigma and how many pi bonds are present in a given molecule. And therefore if you have got something like this kind of structure, whereas there is a double bond, so what would be the number of, calculate number of sigma and pi bond. So here we can easily see, this is representing the carbon atom. All the endpoints of a zigzag chain is representing the carbon. So here it is carbon, this is again a carbon, here is again carbon atom, here is again a carbon atom. So based on this, so it has how many bonds shown? So we can see here only 1 bond is present, whereas the remaining 3 bonds are attached to hydrogen, which are not shown. So you must remember here, all the bonds that are not shown and which is deficient from carbon is representing the hydrogen atom. So we can see here again, here it is hydrogen, here is again 3 hydrogen atoms. So based on this, if we have to count the number of total number of sigma and pi bonds, so we can say number of sigma bonds equal to, we can see here 1, then 2, then 3, then 4, then 5, then 6, here it is 7, 8, 9, 10 and 11. So we have 11 sigma and how many pi bond? Since number of pi bond, as far as number of pi bonds are concerned, it is simply any multiple bonds will have a pi bond. Like in this case, it has only single double bond, so we can say it has only one pi bond. So based on this we can say it has 11 sigma and 1 pi bond. So it's very important to understand. Like similar to this is we can take another example like this one. How many calculate number of sigma and pi bond in this? If I write CH2 double bond, C double bond, C double bond, C H, C triple bond, N. So in this particular case we have to again find out, first of all we will calculate how many pi bonds. So number of pi bonds would be number of pi bonds will be equal to, here it is, we can easily count it like this. Here this is 1 pi bond, here it is 2, here it is 3, and in this case it has 2 pi bonds. So and in this case it is again a multiple bond, so we can say in these 4 situations we will have a pi bond, and therefore we can count the number of pi bonds in this. So in the first case it has only 1. In second case it has again 1 pi bond. In third case it has again 1 pi bond, and in fourth case it has, since there is a triple bond, so it would have 2 pi bonds. So in total it will have 5 pi bonds. 5 pi bonds. Now if we have to find out how many sigma bonds are there, so we can easily find out. As we can see here, in this case it has, this carbon has 2 hydrogen attached, so number of sigma bonds will be equal to, we can easily calculate this again by making carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So we can easily calculate this one as, in this case, number of pi bond. In the very first case it has 2 hydrogen and with this 1 carbon, so it has 3, plus in this case, since 1 sigma bond already shared with this one, so we will have to count only 1 sigma bond for second, so plus 1. Similar to this again for this third one, 1. In case of this, which I have just not marked, is this one, so we can find out, here it is, one with hydrogen, another with carbon, and so it has 2 plus, in this CN bond only 1 sigma, and so it is 3 plus 1, 4, 5, 2, 7 and 1, 8. So it has 8 sigma bonds. So this is one very important aspect of carbon, that it is forming multiple bonds. Another type of question that is frequently asked is finding out the hybridization. So we can easily see here, find out the hybridization in the hybridization in the following molecule. Hybridization of carbon atom present in the given molecule. And so here again we can see here like it is a CH3, so we can write CH3, then CH2, then CH double bond CH2. So what are the hybridization of these carbon atoms? So this is again another challenging question that is frequently asked, and this is really very important to understand. The reason being, this concept of hybridization is letting you know the kind of shape and structure of the concerned atom would be, and therefore you must know this, what would be the hybridization, so that we can easily predict the shape as well. So in this particular case we can see here the hybridization of these. So how do you find hybridization of a particular atom present in the carbon chain? So this could be easily found out basis is simple, like you just need to count number of sigma bonds and you need to identify the number of pi bonds, and overall if you have to calculate the number of hybrid orbital, so we can say number of hybrid orbital equal to number of sigma bond plus number of lone pairs localized. So in this particular case, since there is no lone pair at all, therefore we can see here in the very first case there are 3 hydrogen and 1 CC bond. So in total for the very first carbon you can say it is if I just number them, so we can number it like this. This is first carbon, this is second, this is third, and this is fourth. So in case of first carbon, remember here it's very important to know that only atoms are hybridized, it is not the molecule that is undergoing hybridization. So it's very important aspect, and you must remember this, that the carbon atom is undergoing hybridization process. And so in the very first case, that is if I would have to calculate the hybridization for first carbon, so I can say here hybridization of first carbon, is we can say it has only 4 sigma bonds, and so it would be sp3. Whereas for the second carbon it would be second carbon atom. For second carbon atom we can count it again, and so we found that it has 4 sigma bonds, so again it is sp3. And for third one, for third carbon, it is how many sigma bonds are there? So we can find out the number of sigma bonds would be 3 with this, and so it would be sp2, so that one orbital of s and 2p orbital are mixed together to form 3 hybridized sp2 orbital. And in case of fourth, again it would be sp2. So in this way we can easily find out the number of hybrid orbitals or the hybridization of a particular atom. Let us make it more illustrative using another example. Like next example we can easily take out. I'm just drawing a molecule in which you have to predict the hybrid orbitals of the concerned carbon atom. So if I would have taken this one and like this, so what is the hybridization of these carbon atoms? Again, this is a very interesting to know how do we calculate the hybridization of these carbon atoms, since it has a 1, 2, 3, 4, 5 and 6 carbon atom. So I'm just writing it is a C1, then it is C2, then it is C3, C4, C5 and C6. So based on this, again let us begin to solve this question. Again we can find out in the case of very first carbon, we can see here there is there is two hydrogen attached with the terminal carbon, and through one sigma bond it is attached to carbon, and there is one pi bond. So out of this 4 carbon bonds, we can see there are 3 sigma and 1 pi, and we know that only sigma bonds are undergoing hybridization, and thus we can say it has only 3 hybrid orbitals, that is leading to sp2 hybridization, and thus we can say in first case it would be sp2. In the second case we can see the second carbon which is present here. It has no difference in comparison to the first one, and therefore we can see here again how many sigma bonds are there. So it has 3 sigma bonds, one is through the terminal carbon and another through the middle one, with which there is a triple bond, and 1 hydrogen is present there. So again there are 3 sigma bonds, so again it would be sp2 hybridized. Now in case of third carbon, this is really an important part of the molecule, because it has a triple bond which is known as alkyne, and so in this case it has only 2 sigma bonds, and thus its hybridization would be sp. And in case of fourth carbon it would be again sp. Fifth one, we can say there is no multiple bonds, so it must be 4 sigma bonds there, and so it would be sp3, and again the last one it is sp3. An interesting example that you can easily see here, that is really very surprising and very interesting as well. The reason why I'm calling this interesting, because it is involving a new kind of molecule that you must be aware of. Like if I write it like this one, H2C double bond, then it is a C again double bond, C double bond, C triple bond, CH. So in this case, what would be the hybridization of first, second, third, fourth, fifth and sixth carbon? So I'm just numbering it as well. So this is 1, this is 2, this is 3, this is 4, this is 5, 6. Here the numbering doesn't mean any sequence. I've just arbitrarily written it like 1, 2, 3, 4, 5, 6. So again, if I have to find out the hybridization of each carbon, so we can easily see here how many sigma bonds attached to the first carbon, so we can count it like this: number of sigma bond. If I have to write number of sigma bonds equal to, in very first case we can see here it is 2 plus 1 3. In second it has only 2 sigma bonds. In third again it has only 2. In fourth there is one hydrogen which is not shown in this case, so we can show it there, and therefore it has again 3 sigma bonds, and thus we can say here it has 3 sigma bonds. And in next one, fifth one, it has 2, and in the last one again it has 2. So if you look at the structure of this one, this particular part is called allenes, and when it is accumulated, so we all used to call it cumulines. So this allene has, see what is an important feature of this allene will be its structure, so that we will discuss later on. But in this case, if I have to calculate the hybridization, so we can find out the hybridization corresponding to 3 sigma bonds would be sp2. With this 2 it will have sp, it will have sp, it will have sp2, it will be sp, and it will be sp. So these are the different hybridization of these molecules. So it's very important to know. So we have just identified 2 different class of questions, that in which the very first thing that is frequently asked is the number of sigma and pi bond, and the second one is the number of hybrid orbital involved there. So I'm just taking another example which is describing only cumulines. So if I would have taken like this one, H2 C double bond C double bond C double bond C double bond CH2. So this is called cumuline, that is cumulated alkene. This is cumuline or cumulated alkene. So again the question is very easy, because you have to simply count the number of sigma and pi bonds, and when you have to identify the hybridization, so for that we exclusively are needing only number of sigma bonds. So in the very first case we can easily find out the number of sigma bonds. In the very first, this carbon would be 2 plus 1 3, so it is sp2 hybridized. In second case it has 1 and it is another, so it has 2 sigma bonds, so it will be called sp. In third case again it is nothing different from the previous one, so it will again have sp. Again the next one AJ will have sp hybridization, and in the last one it will be sp2. So these are different examples based on hybridization which is frequently asked in the exams. Now let us move ahead with this, that is with the classification of organic compounds, so that we could discuss some principle called nomenclature, basis which we can give name to the organic compounds, and therefore we'll have a look on the basis of nomenclature of organic compounds. Nomenclature of organic compounds. Organic compounds. This is again a very interesting topic, and it is a very much essential to know how to deal with this. Like when I say it is a nomenclature, see, you must be aware of the basic facts. So I'm just reviewing the basic rules. Like whenever you have a different carbon chain or multiple carbon chain, so you have to select the longest carbon chain. So it is longest carbon chain would be like you can just say rule is longest carbon chain. Longest carbon chain is required to be selected when definitely when there is no other functional group is present. So this is applicable for hydrocarbons, that is a chain having only carbon and hydrogen. Hydrocarbons with no functional group, with no functional group. No functional group. Second is the numbering part. Like it's very important that how to number this. So we can easily see, like numbering is always done so that the branching must fall nearest. So nearest branching, nearest branching. Nearest branching is required. Next one that we can easily see is if functional group is present, functional group. So we can define functional group are those group or those atoms or group of atoms which decide the physical as well as chemical properties of a chemical substance, of an organic substance, is defined as its functional group. So chain with functional group, we must follow the priority order, and a basis that we can give number. So for example, if I say it is the functional group is present, then the preference must be given, preference to the carbon containing functional group. Now if there is a multiple functional group, so in that case what is the priority? So we have to follow the priority order, and so the priority order is something like this. Priority order that you must need to remember, priority order, and some important class of compound. Here I'm just writing down the priority order of some important class of compounds. Like the very first is your COOH, that is called carboxylic acid. Then it is esters like C double bond O, OR. Then we can see here COCl, this is called carbonyl chloride. Then we can write amides, that is CO NH2. Then it is CN, that is called cyanides. Then we have aldehydes, HC double bond O. Then it is ketones, C double bond O. Then we have OH. Then amines, then double bond C double bond C, and then triple bond C triple bond C. So this is the approximate priority order that is to be used while giving numbering to a chain having these functional groups. So let us discuss some of the important example based on this one, like nomenclature. So for that we can easily see how this is to be done. So if I just have to begin with the simple rule, you can easily find out. Like if I have taken this one, so what would be the name of this compound. The process is very easy. What you have to do is, in this case, where is the smallest chain and where is the largest chain? So if I have to find out, so we can easily find out that how many number of carbon atoms are present in the chains, so we can easily number them and we can easily identify the principal chain or parent carbon chain. So we can count it 1, then 2, then 3, then 4, then 5, then 6. In this case 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5 and 6. So if we have this 2 chains with the same length. If I add one more carbon like this, so in this case let us count 1, then 2, then 3, then 4, then 5, then 6. Here it is 1, 2, 3, 4, 5, 6, and in this case 1, 2, 3, 4, 5, 6 and 7. So this will be our principal chain absolutely, and therefore the principal chain would be nothing but this one. And thus, so based on this we can give number. So this is your principal chain or parent chain. You can say this is your parent chain. Now with this parent chain we can, now the next task is numbering the parent chain, numbering the parent chain carbon or parent carbon chain. So let us draw it again, and so we can see, or we can number it like this way. Here it is. So we can start numbering in this following way. Like, we have now two options, either to count it from this side, or in the reverse way. So what is to be followed is, it should be, numbering should be started from the side from where branching comes nearest, and so we can easily see here the numbering must be done from the left hand side. So this would be 1, 2, 3, 4, 5, 6 and 7, and therefore its name would be, since this there is substituent present at third carbon, so we can write the 3-methyl how many carbon in the parent chain? 7 carbon atoms. So therefore we can say this 3-methyl heptane. So this is 3-methyl heptane. Now if I just take another example like this one, that is having more carbon and with some alkene or double bond or something like that. So we can take out this one. There is a double bond, and here it is a branching. Here is a branching. So what is the name of this compound? So for this we can easily do this one again. So the principal chain has no confusion because we can easily count it like 1, then 2, 3, 4, 5, 6, 7, 8. So this is your principal chain. Now the question is, from which side the numbering should be done? So one can easily see here that there is branching nearest to this is on second, and here it is on third. But is it the deciding factor? Not at all. Reason being, there is a functional group, that is your double bond, and we should count it that from the side where double bond comes nearest, and therefore the numbering must be done from this side. So it is 1, then 2, then 3, then 4, it is 5, here it is 6, 7 and 8. So if I have to circle the substituent, so these two are the substituent that has to be circled, and thus its name would be quite simple. We can easily write like since it is having 8 carbon, so for 8 carbon we call it octane. So this is your octane. Now where is the double bond? So it is at third carbon, 3C. It has ene, and it has 2 methyl substituent. One is at second and the another one is at 6th. So it is dimethyl, and thus its name would be 2,6 dimethyl oct 3 in. Remember, the very first letter must be capital and there is no space here. That is dimethyl oct 3 in. So that it will be its name. Now let us look at this another example like this one, where there is a more than one double bond. And so how do we treat those examples? It's again quite simple doing this. Reason being, like if I just take double bond here, then double bond here, and here it is, and here it is. So where is the principal chain? So the very first and most important aspect for this question is to select the principal chain, and it is this one. Like this one is the principal chain that has to be considered, and numbering must be done from this side. So it is 1, it is 2, it is 3, it is 4, this is 5, here is 6, 7, 8 and 9, and so we can say it has 9 carbon atom, 9 carbon atom. So it will be nonane, and it has a double bond present at first one. So double bond at first and at fourth. So it is diene, and it has a 2 substituent at 6th and 7th. So it is dimethyl. So we can say its name would be quite easily. We can say, now we can have this one 6,7 dimethyl, 6,7 dimethyl, nona. Here it is nonane and here it is diene. So how we pronunciate and how do we arrange the name? So we can easily write it in this way: dimethyl, 6,7 dimethyl, then it has nona 1,4, nona 1,4 diene. Or this is also said like 1,4 nona diene. So the name of this compound will be like this one. Let us look at some cyclic compound. For example, we can take this one, If the same thing is to be done for alkenes with this ring kind of structure, so we can say its name would be what? Since it is cyclohexane, since it has 6 carbons, so it is cyclohexane, it would be the parent chain, parent hydrocarbon, and since there is double bond, so we can call it cyclohexene. Cyclohexene. Now if it had some substituent present, so in that case, if it has some substituent present like this one, I'm just adding one more chain to this like this one. So how is the numbering done? Either from this side, that is from top to bottom side, like this is 1, this is 2, or it could be done in this way. This is 1, this is 2. Since in this case lowest number is given to alkene and substituent as well, so this is the right way of numbering, and therefore its name would be, since at 1 it is substituent, so we can write 1 methyl cyclohexene. Now just take another example with this similar kind of structure, wherein there is this one and another substituent present. So in this case the situation is a bit different. Reason being, here it is methyl and here it is ethyl substituent. So in this case what is to be done, that since otherwise the structure would be similar, so we give preference in alphabetical order, and therefore the numbering would be done in this way. It is 1, this is 2, this is 3, 4, 5 and 6. That is one way. If the another way could be like this, it is a like this one, double bond, it is methyl, here it is ethyl, so it could be like this one, 1, 2, 3, 4, 5 and 6. So in this case we can do it like this one. So out of this is 1, 2, 3, 4, 5, 6, and here it is 1, 2, 3, 4, 5, 6. So what way is the most appropriate and what way should be followed? So this choice is very easy. Reason being that whenever there is a double bond, the numbering must be consecutive. That is, the first carbon bearing double bond, then the other number must be second one. Like as you can see in this case, it is 1, then 2, then 3. That is, double bond is carrying the carbon containing double bond is having 1 and then it is 2. Whereas on the other hand, in the second case it is 1 and 6. So which is consecutive? 1, 2, and therefore the very first one is the right way of numbering it. So once we have numbered it, the next part is its naming or nomenclature. So we can write 1 ethyl, 2 methyl cyclohexene. So this way we can give nomenclature to this class of compound. Now we can just move ahead with some more example. Like if I would have taken this one, let us take some example with functional group, and so we can have this OH, or we can take OH, here it is NH2. So in this case what would be the name of this compound, and therefore we need to check the priority order, and since OH comes first or prior to the NH2. So numbering should be done from the side from where OH is nearer, and therefore we can see here it is like 1, and it is 2, this is 3, this is 4, this is 5, and here it is 6. And therefore the name of this compound would be, it is 4-amino hexane 3 all, or hexanol 3. So that can be used there. Now you can take the next example as, if I would have taken OH and here it is COOH. So then the numbering must be done from this side. So it is 1, 2, 3, 4, 5, 6, 7, and so its name would be 5-hydroxy. Now remember, when OH is present at principal functional group, it is all. When it is present as a substituent, then it must be hydroxy. So it is 5-hydroxy heptanoic acid. So this is the another example that we can easily take. Now when there is multiple functional groups present, so in that case we can have another example like this one. If you would have taken this one, COH and COH. So now we can easily see here, if I just start counting number of this one, 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 carbon. So in this chain there is 8 carbon, but has only one COH group as the parent chain. But if I would have taken this one like 1, then 2, then 3, then 4, so it has only 4 carbon, but with the 2 functional groups. So the preference must be given to the chain having maximum number of functional group, not to the chain having maximum number of carbon atom. So it's very important to remember. So you must remember this. It's very important aspect. And so this is the principal chain, and now we'll number it in this way. Numbering must be done from this side only, because if I number it from this side, 1, then 2, then 3, then 4, so branching comes at 3, and from this side branching comes at second position only, therefore it must be counted from this side. So this is 1, this is 2, this is 3, this is 4, and thus we can say its naming would be, at second group, what is the substituent? Substituent is this one, and therefore its name would be 1 carbon, 2nd carbon, 3rd, 4th, and 5th. So we can say 2-pentyl. So its name would be 2-pentyl. 2-pentyl. Now how many COH? It is 2. Therefore we will write 1, 2, 3, 4, 4 carbon. So it is butane. Butane 1,4-dioic acid. So this is 2-pentyl butane 1,4-dioic acid. So we'll take up some more example in the next lecture, and that will conclude our session for nomenclature.